Let's start with examples on indeterminate forms. First example. Evaluate the limit x tends to 0 e raised to x minus 1 minus x upon log 1 plus x minus x. Solution. Given that limit x tends to 0 e raised to x minus 1 minus x upon log 1 plus x minus x. If we put this limit into these functions, we observe that this limit is in zero upon zero form. So we use L'Hospital rule. So by L'Hospital rule, this limit will be equal to limit of the derivatives of these functions. So the derivative of the function in numerator is e raised to x, derivative of 1 is 0, minus 1, upon derivative of log is 1 upon 1 plus x into 1, minus derivative of x is 1. Then I will put again the limit. Then I will find that this limit is again in 0 upon 0 form. So I will use one more time L'Hospital rule. So limit x tends to 0, the derivative of this function is again e raised to x minus derivative of this is 0 upon the derivative of this function is minus 1 upon 1 plus x whole square and minus 0. And I will put this limit into these functions and I will find that the limit is e raised to 0 1 and this is minus 1. So final answer is minus 1. So we conclude that the limit of e raised to x minus 1 minus x upon log 1 plus x minus x as x tends to 0 is minus 1. Example 2. Evaluate limit x tends to 0 e raised to x minus 2 times cos x plus e raised to minus x upon x sin x. Solution. The given limit x tends to 0 e raised to x minus 2 times cos x plus e raised to minus x upon x sin x. If I put 0 instead of x, I will find it out that this is e raised to 0, which is 1, minus 2 times cos 0. Cos 0 is 1, and this is e raised to 0 again 1. So 1 plus 1, 2, 1 minus 2. So this is in 0 by, this is also 0, by 0 form. So we will use L'Hospital rule. So by L'Hospital rule, we have this limit is equal to the limit of derivatives of numerator and denominator function. So limit x tends to 0, derivative of e raised to x is itself e raised to x, minus 2 times derivative of cos is minus sine. So this minus will become plus, and the derivative of e raised to minus x is minus e raised to minus x upon. While differentiating the denominator function, I need to differentiate by using u into v rule. So u into v rule says that I'll keep sin x as it is, and the derivative of x is 1, plus now x as it is, and the derivative of sine is cos x. Now again I will check by putting x is equal to 0 in numerator. What I will find that this is 1, this is 0, and this is 1. So 1 minus 1, 0. Sine 0 is 0, and 0 into cos is again 0. This is again in 0 by 0 form. So I need to differentiate it one more time. So by L'Hospital rule, I will differentiate this function one more time and the denominator function one more time. So let's do it. So the limit x tends to 0, and I want to write derivative over here. So the derivative of this function is e raised to x as it is, plus 2 times cos x and plus e raised to minus x. So this is e raised to x plus 2 times cos x and plus e raised to minus x. And what about the derivative in the denominator? This will be cos x, and again I will apply u into v rule over here. So cos x plus cos x plus, and this is for u into v rule. So cos x as it is, plus x into derivative of cos is minus sin x. Now let's check it again by putting this limit x is equal to 0. But I will find that this is 1, this is 2, this is 1. So I have the limit as 1 plus 2 plus 1 upon, this is 1 plus this is also 1, this is obviously 0 plus 0. So the final answer is, this is 3, 4 by 2, which is 2. So the final limit, that is the limit of the question, e raised to x minus 2 times cos x plus e raised to minus x upon x sin x as x tends to 0 is equal to